Now, integral of the type f prime f of x power of n. Now, we have to remember that from the chain rule, when we differentiate f of x power of n, that gives us f prime power of x times n minus 1 f of x power of n minus 1, which I can rewrite n minus 1 times f prime of x f of x power of n minus 1. Now basically what we're going to do that's if we differentiate, if I go the other way, that's called reverse chain rule. Example. Say if I want to integrate cosine x times sine x power of 2 dx. So we know that the derivative of sine x is cosine x. So therefore here we are exactly in this situation above. So the primitive is therefore, basically because cosine x here is a derivative of sine x inside, so that means that the primitive is sine x cubed over 3, plus c, of course. Yeah, because if we, let's differentiate it. If we let's check. If we differentiate sine cube x over 3, that's going to be 3 over 3 sine square x times the derivative of what's inside, which is cosine x, and indeed that's sine square x cosine x. So more generally, if we just want to extend the rule, the primitive of f prime of x times f of x power of n dx is going to be f of x power of n plus 1 over n plus 1 plus c. Okay, let's do another example. A definite integral this time. So we want to integrate between pi on 3 and pi on 2 sine x cosine square x dx. Now we know that the derivative of cosine x is minus sine x. So that means that the primitive is going to be, so there is a minus sign here, so we just have to be careful. So it's going to be minus cosine cube x over 3 between pi over 3 and pi over 2. Okay, so let's substitute. You know what, I'm going to get rid of the minus sign by swapping the boundaries of integration and removing the 1/3 coefficient. So that's cosine cube of x between pi over 2 and pi over 3. So it's equal to 1/3 of cosine cube on pi on 3 minus cosine cube of pi on 2, which is 0. And so therefore it's equal to 1/3 of what's cosine cube of pi of 3? Cosine of pi on 3 is 1/2, so therefore it's 1/2 power of 3. So it's 1/3 times 1/8, which is 1 over 24. Right. Otherwise, you can do that with substitution. So let's do that with substitution. What I could have done is I could have said, well, let's do u equal cosine x. So that means that du over dx is equal to minus sine x. So therefore, sine x dx is equal to minus du, and so the integral here, and okay, we need also to change the boundary of integration. So when x equal pi on 3, u equal 1/2, and when x equal pi on 2, u equal 0. So the integral is equal to from 1/2 to 0 of sine x dx, well, that's minus du, and then cosine square, so that's u square, which is u square du between 0 and 1/2, which is u power 3 over 3 between 0 and 1/2, and this is equal to 1 over 24. So in that case, you know, they just didn't give you the substitution. You have to figure that out yourself. But you could have done that without substitution. Let's do another one where probably substitution is easier. Let's say we want to integrate tangent square x secant square x dx. So what we know is that the derivative of tangent x is secant square. So what I'm going to do is I'm going to say, oh well, u is equal to tangent x, so du over dx is equal to secant square. So that means that du is equal to secant square x dx, and so the integral become u square, and secant square dx is du, so it's u power 3 over 3. It's an indefinite integral plus c. And we cannot leave it like that, otherwise it would be unfinished, so we just need to substitute back, so it's tangent cube x over 3 plus c.